All right, welcome back to statistics. We are going to continue our discussion on normal distributions. Okay, mostly this is going to be a calculator sort of a walkthrough, but if you need help with using the calculator, there's going to be a lot of examples. Okay, so let's take a look. All right, let me share my screen so that you can look too. All right, so this is the next problem that we are going to be working with. If you need to see up to this, is part one. Okay, part two. Okay, so I'll do a little bit of a description of what we're talking about as well here, but area to the left. Okay, so we have, using a TA calculator, find the area under the standard normal curve to the left of the following values. Okay, so understand that a standard normal curve, right? We say a standard normal curve. I think we have a standard normal curve has a mean of 0 and a standard deviation of 1. Okay, so I recommend drawing these things just for the sake of drawing them, so it's not just like a mindless thing in your calculator. You can actually connect what's going on to like some kind of visual representation. And they want to the left, right? That's this way. Okay, to the left of here is 2.21. This is actually, it's not quite there. And I'll explain that in a moment too. Okay, it's a bit further along. Okay, 2.21. And he went to the left of this. So what I'm trying to do is I want all of this area here. Okay. So remember, in the calculator, we have to do so we're going to do a norm CDF, and we need to give it a min, that's for us to enter, a max, that's going to be for us to enter, a mean, that's u is equal to 0, and then a standard deviation. For this section, it's going to be standard deviation is equal to 1. Okay. So it depends on whether or not we want the left or the right to decide what's the min and what's the max. In this case, we're going all the way from infinity up to 2.21. Okay, negative infinity up to 2.21. So we can't really write in negative infinity, so we have to come up with a reasonable mean, or reasonable min rather. Now, something to remember is that that's 0. Positive and negative 3 accounted for nearly all of the data, right? That was 99.7% of the data from empirical world. So between positive 3 and negative 3, like those are the numbers that are relatively large. Anything that's like smaller than negative 3 is a pretty small number. But we are going to type this thing out to 4 decimal places. So we have to go a little bit more than 3 because that's 99.7% of the data. So we're down to like the 3rd or 4th decimal place here. So what we're going to do is we're going to type in a -10, a -100. The book likes to use 1E99. This is a very, very, very negative number. Okay. And then our max, in this case, this is going to be 2.21. Okay. Mean is 0, standard deviation is 1. Okay. So we type in our norm CDF. I'll probably go -100 just to be safe. Okay. 2.2101, and that's what's going to tell us this area. All right. So we have there's stat distribution, second function distribution here. We want norm CDF, enter, and we're going to say -100. Okay, oops, I want zeros there, not decimal places. Okay, comma, where we're going up to is 2.21, all right, and then 0 and 1. And to 4 decimal places, this will be just fine. If you had to go out to like 64 decimal places, you probably want to use more than -100. Okay, and this is 0.9864. 0.9864. There's a 4 after that. That's not going to contribute anything, so that's going to stay the way it is. So 0.9864. There is our answer. Okay. So this is 0.9864. Okay. To the left of 1.98 is going to be a similar number because 1.98 isn't that far away from 2.21, but it isn't linear. You can't just say, well, this is what, 23 points, 23 basis points away, so we're going to minus 23 basis points there. It doesn't work that way. Okay, it's not a linear process. You can see this graph is curvy, so it's not linear. Okay, so a corresponding decrease in this part is not going to be a corresponding decrease in your area. Okay, very small ones maybe, but this isn't that small. Okay, it's not really that big, but it's not really that small either. So we're going to do norm CDF, right? We're going to type in negative 100, 1.98, and then 0 and 1. These are because they are standard. Okay, in the next section, they will not be standard. We're going to have to do something else. All right, so we're going to type this in. And again, it used to be a much harder process because we used to use tables rather than a calculator. So the calculator, I'm like, I don't know why this is a big section anymore, but I guess not every school uses calculators. Okay, which is, I didn't used to use calculators. I didn't like them. Okay, 1.98. And then, big surprise, right? Okay. All right. 0.97614, right? 0.97614. So we ended up with 0.97614. This 4 doesn't contribute, so that stays by itself. So we end up with 0.9761. Okay. So this was 0.9761. All right. To the left of negative 2.46, this is going to be a smaller number, okay, because it's on the other side of the 0, so it's negative. Okay, so we're going to say norm CDF. Again, we'll say negative 100. Okay, what are we going up to this time? We're going up to negative 2.46. Negative 2.4601. All right, so we're just going to type that in and see where it ends us. Norm CDF. Yep, there we go. So negative 100, there's my low number. My high number is negative 2.46. All right, and then we have our mean and standard deviation. 0.00694, okay, 0.00694. So again, this is not going to contribute, so here we are, 0.0069. Okay, 0.0069. So I'll type this in. We'll have not point not 0.069. Okay, and then to the left of negative 1.52, right, negative 1.52. So I think these are just exercises to get you kind of ready. Type these things in, get a basic feel about what kind of numbers are going to be coming out. So I don't really like problems like this because there's no, even if you don't care about the context, right? Which I can understand that, but there is no context to this whatsoever. So I think I occasionally ask a question like this on a quiz just to can you operate your calculator kind of things, but I wouldn't count on it. Okay, I'm not a big fan of these questions. The most exciting thing about studying statistics is you get to study lots of different things. Okay. All sorts of stuff that uses statistics, and you get to see a lot of it. This was 0.06425.0. Okay, so 1, 2, 3, 4 decimal places. This 5 is going to contribute to that, so we're going to say this is 0.0643 because we're going to do the rounding. Okay, 0.643. Okay, 0.0643. All right. but they are useful. You know, this whole problem set is useful as far as like typing things into the computer, making sure that we're getting the right answers, are we doing it correctly, all of that. So it's not an unimportant skill level to deal with, but I would not be a person to like sit here and look at this and say, this is a very important skill that you have to memorize and live with. Okay. Let's see, we can skip around a little bit. Why wasn't this directly after question 3? Why wasn't this question 4? Okay, this one, again, these used to be hard because we used to have to look these things up on a table, not so much anymore. Actually, this is the easier of the problem because we don't have to think about a min or a max. But, so let's just go ahead and do a couple of these, all right? So if I wanted to say find A, find the area under the standard curve that lies between Z, remember that's the Z score, okay, between Z negative 2.13 and Z equals 2 points or 0.27. Okay, so what are we doing with this? All right. So here's my standard normal, here's my normal distribution, all right? The way I draw these, okay, so mathematicians, we love to connect dots, okay? That's a big thing for us. And if you get 2 points, right, how can we connect these? We could just draw a line between the 2 points. Right? That's one way to go. But a lot of times, right, you'll notice that there's like a little bend in between the 2 dots, right? I could do 2 dots here. We could have a bend like this. We could have a bend like that. All right. We have a name for this. This is called concavity. All right. So if it bends down, this is honestly how you learn. Like when you take Calc 1, this is what you learn. Okay. Now, let me draw a better face there. Okay, this is how they explain it to you. It's concave down, right? Because this guy's down in the dumps. And we have concave up. Okay, it's smiling. Concave up. We have a bend. The bend is like this. This is concave up. This is concave down. All right. So for those of you in calculus, it doesn't matter, business calculus or regular calculus, right? Take the second derivative, set it equal to 0, solve for x, and there you go. That's where your concavity is. What I just described, like, how do you find out where the concavity changes? So we have 3 points, right? We could do something like this, where it goes down and then it changes to up, right? So you kind of change your wrist. Or we don't have a different word. It goes from up to down, okay? This point here, that's called inflection point. Okay, for the people taking calculus, that's what your second derivative test, that's what your second derivative thing is doing for you. It's finding that inflection point, right? Do f prime, f double prime equals 0, solve, and that's your inflection point, all right? So you'll notice the normal distribution, right, has an inflection point, right? We go from concave down to concave up. We go from concave up to a concave down right here, okay? If you, well, I'm not teaching business calculus here, I'm not taking engineering calc either, but one of the questions on my final is always find the inflection points of that function. That's a stripped down vanilla looking normal distribution, okay? That's with mean is equal to 0, standard deviation is equal to 1, and no scaling constants, okay? But there's an inflection point right here. The inflection point is always 1 standard deviation away from the mean, okay? This inflection point is always 1 standard deviation away from the mean. So when I draw my little normal distribution thing, right? Yeah, that's terrible. Doesn't really show what I wanted you to show. But this piece here, right? That distance is about 1 sigma. So when I'm trying to figure out, like, where do I draw my right? Where do I draw my values? I know that that distance, right, this from right here, that's 1. Okay, on the other side, right, go back there, that's -1. Okay, so that's how I'm drawing them. You don't have to do this. Nobody will ever, come by and say, hey, why don't you draw your normal distribution better? Okay, the reason I bring this up is because I've had several students in the business calc class at the same time as this one. And they say, I'd never understood this before, and now I do. So just trying to tie it together with another class so you can do that. If you're never going to take calculus, don't worry about this. Nobody will ever ask you. But if you're ever at a trivia type of thing, and I wonder what that little bend is called. Maybe if you're a parent and your kid is playing connect the dots, and say, what if I connect the dots like this way? You say, that's called concavity. Okay, and then your child will be the smartest one in class. So there we go. But you can make it exciting. You can tie this into like some art, right? If you're going to do like muscle tone or somebody, right? You have concavity. So there we go. Let's see. Why don't we try a couple of these? So I wanted to do this first one. So -2.13, 2.27. Okay. So we're going to figure out the area between this curve. Okay. So here's my normal distribution. So that would be my 1 sigma. So we're going to go 0.27, about a quarter of the way. All right. I should probably just do a different color. Okay. If you're colorblind, blue-green colorblind, I'm sorry. But there's 1, there's about 2-ish. So -2.13. This is 0.27. Okay. And what we're doing is we're trying to figure out that area. But CDF comes to the rescue. Our low number, -2.13. Our high number, 0.27. Standard normal, 0, 1. Okay, there's our good spot. So if we want distributions, okay, CDF, so we have -2.13, comma, 0.27, comma, 0, comma, 1. So we get 0.5, what do we get? 0.58, 58983. Now this number, right, we're going to round it, but it does not, it's less than 5, so we're not going to contribute. So our value, our answer here is 0.5898. Okay, and there we go. All right, so this first one, right, 0.5898. I'm not going to check, but oops, I want 5898. 5898. Okay, but it yells at you if you don't put the leading 0 in there, so we'll do that. Okay, let's do one more. How about we try this one, 0.211 to 0.247. That's not going to be a big number. Okay, so let's go down to where we have it there. So what we're going to do, okay, these really should be symmetric, but here's my 1, here's 2. So we'll call that 2.11, and we'll call this one 2.47. Okay. Go ahead and make a different color here. Pretty. Okay, so here was my 2.11. Here is my 2.47, and we want this little area in between here. All right. So in this case, right, we're going to go back and we're going to say, okay, well, we need normal. So norm CDF. Okay. Our min value, 2.11. Our max value, 2.47, standard normal. Okay, and then we're just going to type this in, and that's going to be our answer. So we want second function, distributions, norm CDF, because we're adding some stuff up. So 2.11, comma, 2.47, comma, 0, comma, 1. Enter. There we go. 0.01, about 1% of the data, 1% of the area is in here. Okay. This is 0.01067. So this is 0.0101234 decimal places. This 7, we'll raise that 6 up to a 7. So there we go. Okay. So that's going to be our values for that one. Okay, let's go through a little bit more here. Outside the interval. Okay. So these are kind of like a two-part problem. I mean, we don't really need to make it two parts, but when we draw it, it'll be like a two-part problem here. Okay. So between negative 1.71 and 1.25. So we want negative 1.71 and 1.25. So drawing a sketch of what we're doing. Okay. So here's our normal distribution. Oops. Put that in with something like concavity there. All right. So we're looking at about negative 1.71 here and about 1.25 here. Okay, it's a mnemonic device. We're not trying to get like real precise with our drawing here. Right? And what we're looking for is we want the outside of this, right? We actually want this area and that area. All right. But it would be easy to calculate. We'd only take one step to do this stuff in the middle here, right? So what we're going to do, all right, is we're going to figure out like, well, what's this area? What's the red area? The brown plus the red has got to be, right? It's all got to be equal to 1, doesn't it? So what we're going to do is we're going to say 1 minus the red area. Okay, and that's going to give us the brown areas. Okay, so 1 minus norm CDF of the low number, negative 1.71, the high number, 1.25, standard normal, 0, 1. Okay, and that's going to be how we get the outside areas here. Okay, so 1 minus, 1 minus, second function distribution. There's our norm CDF. So remember, we already have the 1 minus in here. We don't need to do any more. So it doesn't need to be a two-step problem. It's just a one-step problem. And we need negative 1.71, comma, 1.25, comma, and it's still standard normal. So it's 0, 1. Okay. Enter, and we would end up with about 15-ish%, right? 0.149, 14928. We're going to round to 4 decimal places, so we're going to say 0.1493. Okay, and that's going to be our value here. Okay. All right. Do we need to do another one? I think we're okay. Let's keep moving here. See what else we have. Find the z-score for the area left of 0.78. Okay, so before they gave us the z-scores, okay, and they said find the area. Okay, so here we go. The previous problems we have given the z-score, find the area. In this problem, they're saying, given the area, tell me what the z-score is. All right. So what we have to do is kind of like you kind of have to go backwards. Okay, we're given the area, and we need the z-score. Okay, so draw this out. Okay, the area to the left is going to be 0.78, so it's more than 0.5. Okay, so we're just going to make a little thing here. We're going to say z is equal to, I don't know, but this area here, this area is 0.78. Okay, so rounded 2 decimal places. By the way, z-scores almost always get rounded to 2 decimal places. Probabilities get rounded to 4 decimal places. Okay, it's a rule. Okay, so we have to figure out how to do that. Well, we would need a table, right, or some kind of a chart to do that. Okay, even calculus, that would be an extremely difficult problem. So what we're going to do is we're going to say second function distribution. Oops, I want second function distribution, not drawing. Quit. There. Okay, we're going to do inverse norm. Okay, so we're going to give it the area point. Oh, I don't want that. So inverse norm, and we're going to say 0.78. I think we need 0 and 1 here to let it know that it's a standard normal. Okay, but it might not. Again, if you have a TI-84, it's a little bit easier because it prompts you to do the various things. Okay, if you have a TI-83, you're kind of stuck with like memorizing this thing. Okay, we're going to test this. We're going to say 0.77. That was right. Okay, so the format is we're going to say inverse norm. You're going to put the probability first, right? That was the area. Then you're going to put the mean and the standard deviation. And that's going to be how we're going to get this z-score. So the z-score was 0.77. Okay, I really wish they would have picked a different number because these are not usually the same. Okay, there is a spot where they are, but they're not usually the same. And then they happen to pick the one that is the same thing. Like, really? If you're ever going to become a teacher, or if you're trying to, come up with questions, the thing you don't want to do is to come up with a question where a student just takes a wild guess. You don't want that to accidentally be the answer. And in this case, right, with round off, it's like, I mean, this will mark you wrong. But if a student said 0.78, I'm like, maybe they typed in something a little off for their computer. I wouldn't be able to tell if they just guessed 0.78 because that's the number they were given and they decided to guess, or if they actually did the correct thing. So if you're ever going to be a teacher, you want to avoid questions where if a student just wildly guesses at the answer, it's not the right answer. Okay, like you want to avoid this question. What is like 2 squared? And then your multiple choice is like 4. Because what if the student did this? They get the right answer. What if the student did this? Which is technically what you're doing, right? Because 2 squared is 2 squared. But you'd really like this operation to have been done. But all of these give you 4. So this is a terrible question. All right, let's try another one. The area to its right is 0.27. Now this one is a 2-part question. So here we go. We are given that the area to its right is 0.27. That's less than 0.5, right? 0.27 is a smaller number than a half. So it's somewhere up here. Okay, I don't know where, but if it was more than a half, I would have drawn the z-score down here somewhere. Okay, so this one, we don't know. So from here forward, everything's a half, right? So it's less than a half over here. All right. So this answer is what? This answer is 0.27. All right. What I think we have to do, because the normal inverse function only tells you from like from negative infinity up to that point. Okay. So what we need to do is come up with like, well, what's on the other side? No, we won't. We'll do this color green. Okay. What is this area? Right, we know this area is 0.27. What's this one got to be? That's got to be 0.73, right? If something costs 27 cents, you pay $1. How much change do you get? So it's 1 minus 0.27. That's going to be 0.73. Okay, that's how I got this area. So what we're going to do is we're going to say norm inverse, right, of 0.7301. Okay, so that's norm inverse 0.7301. That'll tell us this value because it doesn't matter, right? It's the same z value if 27% is on the right or 0.73, right? 73% is on the left. It doesn't matter. But the calculator is only going to do it one way. So what we're going to do is say, well, it's got to be this one. We are not finding a probability. So the 1 minus trick ain't going to work because that works for probabilities. Z-scores are not probabilities. Okay, so you can't just do that little trick of like 1 minus. We can do it with probabilities, which is how I did this. But if I say 1 minus norm inverse, we are not going to get the right answer. It's not why I did that. So we are going to type in, say, okay, second function distribution, inverse norm. Okay, we wanted 0.73. Okay, the mean 0, standard deviation 1. All right, and here we got 0.6128. So 0.61, that is our value for this z-score here. 0.61. Okay. Oh, they wanted the 0.61. Thanks. So those are going to be a little tricky, all right? But these used to be much trickier, but they're not so bad now. Okay. Oh, find the z-score that bound the middle 80. I love these. If you have to bet on a question I'm going to ask you, this is the one. Okay. So find the z-scores that bound the middle 80% of the area under the standard normal. Let's draw what's going on. All right. We'll use gray. Maybe use gray for a while. What I want to do, right? They said the middle 80%. Here, this is 80% or 0.80. Okay. And we have to figure out like what's this and what's that. I don't know. But what are we going to figure out? How much is left? Okay. We had 80% accounted for. How much do we have left? That would be 20%, right? 1 minus 0.8 equal to 0.2. They wanted the middle 80%. So we have to divide this into two different spots. So we've got 10 cents in this area and 10 cents in that pocket. So we have 10 and 10 is 20 plus our 80, that gives us $1. Okay. So what we have to do is we have to figure out, well, what the heck is this number here? So we know this area here, right? This is 0.10. This is symmetric. So whatever happens here is going to mirror and be on the positive side over there. All right. So what we're going to do is we're going to say norm in. Right? How much area do we want over here? We want 0.10 with a 0 and a 1. All right. So we're going to type in second function distributions. Okay, inverse normal. Okay, we want 0.1. Okay, and then again the mean and the standard deviation. Okay, and then this is going to tell us negative 1.28. Okay, so here we have negative 1.28. If we fold this over, it will fold over exactly. What's this one going to be? Positive 1.28. Let's check. How can we use these numbers to generate this area? Well, we're going to say norm CDF of the low number to the high number, mean standard deviation. We had better get 0.8 or something very close to it. Okay, we're going to type in second function distribution, normal CDF. Okay, we're going to say negative 1.28, 1.28, comma, 1.28, comma, 0, that's my mean, comma, 1, that's my standard deviation. All right, and it equals 0.79945. Okay, so not quite 0.8, but really, really close to it. Okay, so I'm happy that we are bounding the middle 80% with these two numbers. Okay, so one of my favorite problems. 0.28 and 1.28. All right. Let's see if we actually deal us another one. The middle 96%. Beautiful. They did deal us another one. So we're going to do the same thing. Okay. So we're going to check. We're going to say, okay, here's my normal distribution. Okay. We are trying to figure out the middle 96%. Okay. So we're going to notice these are all even so far, so that's very convenient for them. We'd have to go into halves if they weren't, but you know, whatever. Okay, I think even I like to pick even numbers for this because it does make it just that much easier. So what are we doing? We're saying this is here. This is 0.96, right? This area here is 0.96. How do we get the other areas? How do we get this area? What's there? Well, 1 minus 0.96, this will be 0.04. You've got 4 pennies left over. So we got to put 2 pennies here. We're going to put 2 pennies over there. Okay? So this number and this number, that's what we're going to need. Okay, so we're going to say norm inverse, because we want a z-score, of what? Of 0.02. Because norm inverse goes from negative infinity up to whatever number you want to stop at, in this case 0.02. Okay, or the area for this is 0.02. Okay, and we want to do 0 and 1. Okay, so let's type that in. Okay. So we're going to say second function varies norm inverse. Okay, enter. So 0.02, and then mean standard deviation. Enter. Okay, negative 2.05. This is negative 2.05. Whatever happens on this side is going to happen on that side. Okay, so we're going to say plus 2.05. Okay, so that would be my answer there, between negative 2.05 and positive 2.05. So let's check. All right, let's just double check ourselves to make sure. So we're going to say second function distribution, norm CDF. Okay, and we're going to do negative 2.05, comma, to positive 2.05. We need our mean and our standard deviation. Okay, and we should get 96%, or close to it. Okay, 95696. So this is the 2 decimal places, right? This is 96%. So we're pretty good. Okay, so that's again, of all the problems we've done so far, This one has been my favorite one. Okay, so make sure you're looking at that one, and you know how to check your answer. You know how to set it up, how to carve it up to get the right answer. So you'll be okay. All right. So practice number 10. Okay, as many times as you need to. But you should be fine with being able to do this one. All right. All right. Good luck. I will see you in the next section, which is going to be 7.2, I believe.